RE-NEET chemistry exam is coming. Here is the revision of most important repeatedly asking topics from chemistry. If you spend 5 minutes, 20 marks yours. So let us start the video. Carbon molecule. Each carbon atom contains 6 electrons because atomic number of carbon atom is 6. So carbon molecule contains 12 electrons. Now we will arrange those electrons in the electronic configuration of carbon molecule. The electronic configuration of carbon molecule is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. Wherever there is a star, that is anti-bonding molecular orbital, and wherever there is no star, that is bonding molecular orbital. Now we will find out the bond order. To find the bond order, we have a formula. Bond order is equal to half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. So in bonding molecular orbital, we can find total 8 electrons, and in anti-bonding molecular orbital, we can find 4 electrons. So when we substitute and calculate, we will get bond order 2, which means between two carbon atoms in carbon molecule, there are two bonds, one sigma bond and one pi bond. So in the electronic configuration, we cannot find any kind of unpaired electron because all the electrons are paired. Carbon molecule is diamagnetic. It will not attract to the magnet. One more very important molecule here is oxygen molecule. Oxygen atomic number is 8. So oxygen molecule have 16 electrons. Let us see the electronic configuration of oxygen molecule, O2 molecule. The electronic configuration of oxygen molecule is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2px2, pi 2py2, it is repeated, pi star 2px1, pi star 2py1. So total there are 16 electrons: 2, 4, 6, 8, 10, 12, 14, 15 and 16. So we can find here unpaired electrons, two unpaired electrons. Because of the presence of unpaired electrons, it will attract the magnet. Now let us find out the bond order. So we can find bonding molecular orbital. In the bonding molecular orbital, we can find the electrons 2, 4, 6, 8, 10, 10 electrons, minus in anti-bonding 2, 4 and these two electrons 6. So 10 minus 6 is equal to 4. So 4 divided by 2 is equal to 2. So in oxygen molecule, bond order is 2, which means between two oxygen atoms in oxygen molecule, there are two bonds, one sigma bond and one pi bond. So because of the presence of unpaired electron in pi star 2px and pi star 2py, oxygen molecule is paramagnetic. Because of the presence of unpaired electrons, oxygen molecule is paramagnetic. It attracts the magnet. Next, thermodynamics property, very important, intensive property. Intensive property is the property that does not depends on the quantity of the matter present in the system. Example, temperature, density and pressure. Similarly, extensive property also very important. Extensive properties are those properties which actually depends on the quantity of matter present in the system. Example, mass, volume, internal energy, enthalpy and heat capacity. Here examples are very important to the exam. Another very important topic here is based on delta G, based on Gibbs free energy, how to decide spontaneity of the reaction. If Gibbs free energy is less than 0, that process is spontaneous. If delta G is exactly equals to 0, the process will be equilibrium. If delta G is greater than 0, the process will be non-spontaneous. This is also very important to the exam. In the redox reaction chapter, they'll ask to remember you the oxidation number of oxygen. Oxygen oxidation number is -2 with some exception. Exceptions like in peroxide oxidation number is -1 like hydrogen peroxide. In superoxide oxygen oxidation number is -1/2. If oxygen is with fluorine, then in case of OF2, oxygen oxidation state is +2, in O2F2, oxygen oxidation state is +1. From structure of atom, most repeated question in the NEET exam is quantum number. The first type of quantum number is principal quantum number. And children, principal quantum number specifies the size and energy of the orbital. The symbol is small n. Larger the n, larger the size and higher the energy of the orbital. Second quantum number is azimuthal quantum number that determines the shape of the orbital, that starts with the azimuthal quantum number value L is equal to 0 to n minus 1. For example, for s orbital, L value is 0, for p orbital it is 1, for d orbital it is 2, and f orbital it is 3. So azimuthal quantum number help us to determine the shape of the orbital. And magnetic quantum number m, it indicates the orientation of the orbital in the space. It starts with minus L to plus L. For example, for p orbital, azimuthal quantum number value is 1, and magnetic quantum number for this starts with minus 1 0 plus 1, minus 1 0 plus 1. Minus 1 means p orbital in px orientation, y means 0 means py, and plus 1 means pz. So p orbital has three orientation, px, py, and pz. Last quantum number is a spin quantum number. Spin quantum number determines the spin of the electron, whether the electron is moving in clockwise direction or in anti-clockwise direction, plus half or minus half. Very important topic one more here is about carbocation. Remember, carbocation, carbon has a positive charge. It is carbon atom is sp2 hybridized, and the geometry is planar. Carbocation geometry is planar, and tertiary carbocation is more stable. In case of carboanion, we can find negative charge to the carbon atom. The geometry is pyramidal, and the hybridization is sp3. And remember here, methyl carbanion is highly stable, and tertiary carboanion is least stable. Come to free radical. In case of free radical, the geometry of the free radical having odd number of electrons, the geometry is planar, hybridization is sp2. Here also tertiary free radical is more stable.